Now they've given us a graph at the top of page 166 of negative x to the 4, which isn't one of the graphs that we know. And they want us to see what this graph is going to look like. I'm just going to check what color they're going to use. Blue. Cheat and make the blue go away. So I'm going to put a blue box around this because they're going to graph that in blue. And I'm going to take the time to rewrite that with y all by itself. So it would be negative x minus 2 to the 4, and then I would add 4 to the other side. The original graph in red was y equals negative x to the 4. So just looking at the equations, we want to see what's the same, what's different. Okay? Well, we have a negative out in front in both of them. We have an exponent of 4 in both of them. That's what's the same. What's different is now there's an x minus 2 inside where the x was, and there's a plus 4 outside. The minus 2, that will move it 2 to the right. The plus 4, that will move it, not 4 up. And so when we look at the graph, it's been moved 2 to the right. We can take a key point like 0, 0, and it moves 2 to the right and 4 up to get to that point there. And so unlike the first example, this one has two translations combined. And we saw this in our pages that we did earlier as well. Okay? If I wanted to write this in function notation, if I said my original graph was f of x, how would I write my blue graph in function notation? Well, what's happened? It's moved 2 to the right and 4 up. In function notation, my blue graph would be 2 to the right would show up as f of x minus 2. 4 up would show outside as plus 4. Notice that the exponent of 4 and the negative do not need to be written because they were included in the original function. So in function notation, you're just showing the translations that occurred. So again, they have a shaded box here. You can write this again with y by itself, because we're going to be using that notation more often with that plus k afterwards. So when we go to example 2 now, we've got some sort of funky W graph that's written in function notation as j of x. Sketch the image of the graph after a translation of 4 units left and 5 units down. So what I would do is I would look for some key points. These ones look like key points. This one looks like a key point. And I would take those key points and I would write, and I would move them 4 to the left, 1, 2, 3, 4, 5 down, 1, 2, 3, 4, 5. Make that first point. Take my second point at 2, 1, 2, 3, 4, 1, 2, 3, 4, 5. Mark that point. Take my point at point 5, move it 1, 2, 3, 4, 1, 2, 3, 4, 5. And then draw my graph with the same shape, putting arrowheads on the end, even though the original graph didn't have the arrowheads. And we've given the sketch of the graph. Write the equation of the image graph in terms of the function j. So for my blue graph, if I want to show a translation left and right, that happens inside my function. So if I want to show 4 to the left, I would have an x plus 4 inside of my function. And then 5 down would show up as minus 5 afterwards. state the domain and range of each function. So we'll do the red one first. My domain is everything. My range is y values are greater than or equal to 0. Then right beside it, my domain is still everything after I've moved it left and right, but now my range is y is bigger than or equal to -5. Okay, so right above the question, you can write 8, 9, and 10.